Welcome to Practical PyTorch. In this video you'll learn how to read a tensor, how many axes it has, its shape, which tells you how to read the numbers, the D-type of those numbers, and how to pick numbers out and reshape them. Let's start with two errors. The first says two shapes cannot be multiplied, a shape problem. The second could not infer an output D-type and it got long, a D-type problem. A tensor is just a grid of numbers and it carries two labels, a shape and a D-type. Get either one wrong and your code breaks, often with no warning. This video makes both of them easy to see. This video has 4 parts. First, what a tensor is, one number, a row, a grid, and bigger. Second, shape, how to read the numbers inside a tensor. Third, D-type, what each of those numbers actually is. And fourth, indexing, slicing, and reshape, how to get at the numbers. Let's start at the beginning. What is a tensor really? We'll build one up from a single number to a stack of grids. Start with a single number all by itself. That's already a tensor. It has no axes at all. PyTorch calls this a scalar, and its rank is 0. Rank just means how many axes it has, and here that's none. Now put several numbers in a row. That gives you one axis, and PyTorch calls it a vector. To point at a number in the row, you say how far along it is. This is the first one. And this is the third. One number is enough to find any of them, so a vector's rank is 1. Stack rows on top of each other and you get a grid. PyTorch calls this a matrix. Now one number isn't enough to find a cell. To reach this one you need 2, the row and the column. 2 numbers to reach any cell, so a matrix's rank is 2. Now put grids behind each other. This is the grid at the back. And this is the grid in front of it. 2 grids stacked gives you 3 axes. This is a 3D tensor, rank 3. PyTorch doesn't stop here. A batch of color images is a 4D tensor. Let's read the whole ladder from the left. A single number is rank 0. A row is rank 1. A grid is rank 2. And a stack of grids is rank 3. So rank is simply how many axes a tensor has. In code you read it as x.ndim. Same idea, 2 names, and both of them show up in error messages. Let's make some tensors with 4 calls you'll type all the time. Torch.zeros, 2. 3 makes a 2 by 3 grid and fills every value with 0. Torch.ones makes the same shaped grid, but every value is 1. Torch.randn makes the same grid, filled with random values. And torch.tensor takes your own numbers, here 1 point and 2 point, and builds a tensor from them. So the first 3 are told the shape you want. The last one is told your numbers, and works the shape out for itself. Now the shape. The shape is the list of numbers that tells you how to read a tensor. Let's build one tensor and look at it from every side. We'll use this one tensor for the rest of the video. X equals torch.zeros, 2, 3, 4. Here's the first plane. And here's the second plane, so that's 2 planes. Each plane has 3 rows and 4 columns. 2 planes, 3 rows, 4 columns, and that's 24 zeros in total. The shape is written as a tuple, and here it's 2, 3, 4. You read it left to right, 2, then 3, then 4. Each of those 3 numbers belongs to one axis. We're about to point at all 3, one at a time. The first number is dim 0. Dim, dimension, and axis all mean the same thing here. This axis runs across the planes. There are two planes, so dim 0 is 2, and that's the first number in the shape. The second number is dim 1. This axis runs down the rows. Let's count the rows in a plane. Row 1, row 2, and row 3, so dim 1 is 3. The last number is dim 2. This axis runs across the columns. Let's count the columns in one row. Column 1, 2, 3, and 4, so dim 2 is 4. 3 numbers, 3 axes. Let's print it. Print x dot shape. The output is torch size, 2, 3, 4, exactly the 3 numbers we just walked. Then print x dot ndim. And that's 3. The shape has 3 numbers, so the rank is 3. Torch size behaves like a tuple, so x dot shape at index 0 is 2, and 3 numbers in the shape means ndim is 3. Here's the big idea of this section. In memory, there are really just 24 numbers sitting in a row. The shape is what does the work of arranging them. It tells PyTorch to read those 24 numbers as 2 planes of 3 rows of 4 columns, and that idea is exactly what makes reshape cheap, which is our last section. Now the Dtype. The shape tells you how many numbers there are and how they're arranged. The Dtype tells you what kind of number each one is. The Dtype is the type of every number in the tensor. One Dtype for the whole tensor, not one per number. See the dot after this number. A dot makes it a float. This Dtype is float 32, and it's the default. It's also what most neural network layers expect. You get it just by writing a dot. Here's the float row again. 1 point, 2 point, 3 point, each with a dot. Now write the same numbers with no dot at all. Just 1, 2, 3. PyTorch makes these whole numbers, and the Dtype is int64. Same 3 numbers, different Dtype. And nothing warns you, nothing looks wrong. Comparisons give you a third Dtype. Ask a question of a tensor, like is each number greater than 0, and you get back a bool tensor. Each cell is now just true or false. The bool tensor has the same shape as the tensor you ask about, and you can use it to choose values. Let's print a Dtype. Print torch.zeros2 3.dtype. It says torch.float32. Zeros come out as floats by default. Now print torch.tensor 123.dtype. This one says torch.int64. Whole numbers, no dot. 2 calls that look almost alike. One gives you floats, the other gives you whole numbers. Your turn. Here we build torch.tensor with 1, 2, and 3.0, 2 whole numbers and 1 with a dot. What Dtype does this whole tensor get? Pause and guess. Okay, here it is. It's float 32. 1 dot is enough. Because one of the numbers has a dot, PyTorch makes the whole tensor float 32. Here's the bug that int64 causes. We call dot mean on a tensor of 1, 2, 3, and it crashes. Mean needs a floating point type, but it got long. Long is just the old name for int64. And notice, the line that crashed the mean is not the line that made the mistake. The mistake was building the tensor with no dots. There are 3 ways to fix it. First, put a dot in every number. 1 point, 2 point, 3 point. Second, name the Dtype yourself. D, type equals torch.float32. Third, build it and convert afterwards with .float. And the best habit of all, print x.dtype as soon as you build a tensor. One line and you catch the dtype bug right where you made it. Last part, you can read a tensor now. Let's pull single numbers out of it, take slices, and reshape it. Indexing works just like NumPy, one number per axis and every axis starts at 0. This cell is x at 0, 1, 3, plane 0, row 1, column 3. One cell, one number. Ask for x at 0, 1, 4 though, and PyTorch stops you. Column 4 doesn't exist. The columns are numbered 0, 1, 2, 3. Now give just one number. X at index 0 grabs this whole first plane, all of it. Its shape is 3, 4, one axis fewer than before. Giving one number for an axis drops that axis, so the rank goes down. Let's print both. First, print x at 0, 1, 3. The output is tensor, 0 point. One number wrapped as a rank 0 tensor, a scalar, just like the very start of this video. Then print x at index 0 dot shape. And that's torch size 3, 4. The plane came back with shape 3, 4. Reshape gives the same numbers a new shape. Here's our tensor again, shape 2, 3, 4. Count the numbers first. 2 times 3 times 4 is 24 numbers. Remember that count. On the left, the same 24 numbers, shape 2, 3, 4. We call x.reshape 6, 4. And on the right, 6 times 4 is also 24. Same numbers, same order, just read a new way. 24 numbers on the left. And 24 numbers on the right. The counts match, so this reshape is allowed. A reshape is legal only when the counts match. Ask for x.reshape 5, 4, and PyTorch raises an error, because 5 times 4 is 20, and 20 numbers is not 24 numbers. Let's recap. Shape says how to read the numbers. You get it from x.shape. Dtype says what each number is. You get it from x.dtype. Rank is how many axes there are. You get it from x.ndim. And here's the promise from the start. A shape error and a dtype error are just one of these three being wrong. So print all three before you debug anything else. So now you can read one tensor completely. Next, we put two tensors together. Add a row of 4 numbers to a grid of 3 by 4, and PyTorch quietly stretches the row to fit. That's called broadcasting, and it's the next video. I'll see you there.